single line you can see single input and many many output, just a reverse of mux. In the mux having a many input single output, but in the demux single input many output. So what is the block diagram? So it's the block diagram is like this one. uh, this one is a mux. Suppose this one is the denoted at the 1 is to 4. So 1 is to 4, 1 is to 4 demux, 1 is to 4 demux. That means one input and four output, one input and four output. And how many selection lines? So two selection lines, two selection lines. So simply we can say the I is the input, I is the input. Suppose that y naught, y1, y2, and y3. This is the output, and selection line is s naught and s1. This is the selection line. So simply in this demux, so input. This is the input. This part is your output, and this one is selection line, selection line, or control line, or control line. Yes. So or you can design like this one is the demux. So this is the block diagram of demux. So one input, four output, four output, and this is the selection line. So this is called 1:4 demux. 1:4 demux. 1:4 demux. So or you can write only demux, no problem. So D or somewhere the written as the only demux. So you can choose that one. Okay. So this one is the input is I, and here the output is y naught, y1, y2, and y3, and this one is the selection line s naught, s1. This is the input. This one is the output, and this part is the selection line or control line. So is that clear, or anyone have any doubts, any query up to this point? So
Clear,
demux,
sir.
Understood.
so demultiplexer or demux. So demux, simply called DEMUX or demultiplexer. So DEMUX is a combinational circuit, combinational circuit, which have one input, which have one input and many output, many output, many output depend on depend on select depend on select input. Yes, select input, and that input is transferred trans input is transferred input is transferred to any of the any of the output, any of the output, where the input is transferred to any of the output, and it is also known as known as it is also known as one to many. Sorry, it is also known as one to many. It is known as data distributions, and data acquisitions is known as MUX. So data distribution, it is known as serial to parallel, serial to parallel, serial to parallel data distributions like this one. So this is also known as like this. So what is the meaning of serial to parallels? Means here the data is entered serially, and output is a parallel. That's why called a serial to parallel. And single to many. So it is called also one to many. Yes. So up to this point, anyone have any doubts, any query? Everyone give your response. Okay. So first now I'm choosing
Clear, sir.
one is to two marks. So first now I'm discuss with you one is to two DEMUX. One is to two DEMUX. So one is to two DEMUX. So it's a block diagram is uh, this one is the block diagram, means one input, two output. So one input and two output. So how many selection line? So that one is the depend upon output, how many output, and it's the values of n. So this n is decide the selection line. So selection line is one. So suppose that that selection line is S, input is I, and output is suppose Y naught and Y1. So this is the input or output. Or you can simply design like this. This suppose this is the input I, and this one is connecting to y naught, or this one is connecting to y1, y1. So it's the values depend upon this values. So this is called I, and this values is controlled by a switch. This is called as control line or selection line S. So what is this I is the input, I is the input, and y is the output, and this is a select selection line or control line, selection line or control line. So when the values is s, it may be 0, or s it may be 1. Selection line it may be 0 or it may be 1. So when the switch s values is 0, this switch is connected to the position of y naught, and here you got the values. Here you got the values. So this is, so when s equal to 0, this I is connected, this switch is connecting to here. So what is the value here? What is the value here? So that value is equal to y naught. So what is the value of y naught? This value is s bar I, and when s is connecting to that value is 1, when s is connecting to 1, so this switch is connected to here. So what is the value? So this is equal to s into I. So only the change is here. So s is 0 or 1. So 0 connected to here, and when s is 1 connecting to here. So in that case, so finally you got the expression for y naught. So this is equal to s bar I, and for y1 this value is s into I. So 0 y connecting to y naught, and when 1 this one is connecting to y1. Is that clear, or anyone have any doubts, any query? So what is the truth table here? So how to design this expression? So first now here we have draw the truth table. So through a truth table, or what is the input here? So one is the selection line. Selection line is the input, and output is y naught and y1, y1, y1 and y naught. This is the output. So when the s is 0, when the s is 0, so this one is the open, so its values is 0, and y naught is 1, and when the s is 1, 1, this one is connected to here I, this is I, and this values is 0. So this is the expression of a truth table. And what is this n? So this n is a selection line, selection line. So finally you got the expression what is the value of y naught. So finally you got the expression y naught equal to just see this value I into s bar. So simply say that the s bar I. And what is the value of I1? So it's the value of s into this one. So this value is s I. So I hope is that clear to all, yes or no, or anyone have any doubts in query?
Clear, sir, no doubt.
So how to design the circuit? How to design the circuit? So we have a two outputs. So here one AND gate, here one AND gate, two output. So just see that how to design the circuit. So here I am using a one AND gate, one AND gate, and this one is the one AND gate, one input, and here one input is I. So this I is the input, and this input is connecting to both here and here. Yes. Now the another line is a selection line. So just now I'm connected here the values s. So this one is directly connected to here. So what is the output here? So output is s I, and here we have connecting not gate, and then finally this one is. So what is the value of this one? S bar I. So what is the output? So this is the y naught, and this is called y1. So this is our circuit. So which logic, which gate is used for the designing of DEMUX? Only AND gate, AND gate. So this is the output part. This one is the input side, and logic gate is here AND. This one is the AND. So the question is, which gate is used for the designing of DEMUX? So AND gate, and for MUX, AND OR logic gates, and for DEMUX, AND gates. Yes, and when I'm designing, this is 1:2 DEMUX, 1:2 DEMUX, 1:2 DEMUX. So two AND gate is needed. Two AND gate is needed. Yes. So similarly, suppose if you want to design 1:4 DEMUX, so how many AND gate is needed? Four AND gate is needed. Anyone have any doubts? Any query?
No,
Yes
sir,
or no?
not sure.
So first, now I'm discuss with you. 1:4 DEMUX. 1:4 DEMUX. So what is the meaning of 1:4 DEMUX? 1:4 DEMUX means this is a MUX. This one is a MUX having only one input. And how many? Four is simply you can write down the 4 is 2 raised to the power 2. So this 2 is a selection line, and 4 is the output. 4 is the output. So suppose I is the input, output is y naught, y1, y2, y3, and selection line is s naught and s1. So this is called 1:4 DEMUX. 1:4 DEMUX. So what is the output? So final expression. So when you have simplified this one, so what is the output here? So this depend upon this selection line. So suppose I'm writing here the truth table. truth table. So what is the expression? So one is the S1, S naught. This is the input part, and output is Y naught, or simply you can writing in the reverse order S3, Y3, Y2, Y1, and Y naught. Yes. So this is the input part. So the combinations is both is 0, 0, 0, 1, 1, 0, and 1, 1, 1, 1. Yes. So both is 0, 0, both is 0, 0. Simply which one is connected to? Y not? So you can connect like this. This one is I. Or simply say 1, 1. And all others are 0, 0. Suppose you have connecting to 0, 1. So connected to Y1. So this value is 1, I, and other values is 0, 0, 0. Similarly, 1 0, so this is 0, I, 0 0, and 1 1, so here the I and this term is 0 0. So this is the truth table. So this part is output part. These four are the output, and these two is the input as a selection line. So what is the final expression for Y naught? So Y naught expression is S1 bar, S naught bar, I. What is the expression for y1? So y1 is s1 bar s naught I. What is the y2? So s1 s naught bar I. And what is the y3? S1 s naught I. So this is the logical expression. So how many AND gate? Four AND gate is needed for the designing of these expressions. So can you design? So just you can here use it's the values is like here I'm choosing the value suppose s 1, then invert this one, so its value is s not s1 bar. Similarly I'm choosing this value is s naught and connect here a one not gate. So again this value is s naught bar, s naught bar. On how many AND gate? Four AND gate. So one AND gate is this one AND gate, one AND gate, and one AND gate. So four AND gate is needed for the output. Four AND gate. And now here I'm taking the values. One is the I. So I is the common for all. So just now I'm taking a one value I for all. I. This one is I. This one is I. This one is I. So first output is Y naught, and Y naught is S1 bar, S naught bar I. So where is the S naught bar and S1 bar? So this is the S naught bar, this is I, and this is S1 bar. Similarly, the next is I. So next output, that one is the Y1, and its the values is S1 bar S naught I. So I is common, then S naught. So S naught is connecting here, and then S1 bar. So this is the S1 bar. Again y2. So what is the y2? So s1 s naught bar I. So I is connected here, then s naught bar is connected here, and then s1 is connected. So s1 is this one, and y3, this value is s1 s naught I. So I is already connected here, then s naught, and then s1. Yes. So this gate is AND gate, this gate is AND gate, AND gate, AND gate. So this is called 1 is to 1 is to 4 mux, 1 is to 4 DEMUX. So how many AND gate? 4 AND gate. So understood everyone, or anyone have any doubts, any query? Is that clear up to this point? If anyone have any doubts, any query? 8, 8 we can write down this is 2 it is to the power 3. So this 3 is a select line. This 3 is the select line. So it's the 8, 1 is to 8 mux is DEMUX is like this one. So how many inputs? So single one input, 1 is to 8 DEMUX, DEMUX, and selection line is 3 selection line. So simply called S0, S1, S2. The input is suppose I, and output is 1, 2, 3, 4, 5, 6, 7, and 8. So it's the output is Y0, Y1, Y2, Y3, Y4, Y5, Y6, and Y7. So this one is the input, and this one is output sections. So output sections, and this is the control line or selection line, select line. So what is the output here? So output, finally your output is depend upon this selection line, and is the three inputs. So it's the truth table is like this one. You can draw it's a truth table. Suppose S2, S1, and S0. This is the three input selection line, and what is the output? Output is here you have write down the output of the expressions. Output. So if all 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, double 0, 1, 0, 1, 1, 1, 0, and triple 1. This one is the combination. Or simply you put here the at the output side, the terminal you can write on here. You can write on the expression like this one is the suppose y naught, y1, y2, y3, y4, y5, y6, and y7. Just to check it, just put the values is here 1 1. You can put here the I, or you can put the here 1, so no problem. So here the values is suppose I means here 1, then the rest of the term is 0 0 0 0 0. So this is the truth table. And similarly here the 0 I, 0 0 0 0 0 0. That means here the terms is diagonally 1, diagonally I, and next of the term is 0 0 0 0 I, and then term is 0 0 0 0 0 I, 0 0 0. So here you got the finally diagonally I. So this diagonal is I. Or if suppose someone start from y7, y6, then this diagonal is I. So this is the truth table. Or in this way, you can write down the expressions, logical expressions. What is the value for y naught? So y naught is s2 bar, s1 bar, s naught bar, I. So its expression is s2 bar, s1 bar, s naught bar, I. So simply you can write down the expression like this one. So what is the expression for this? So this one is S2, S1, S0, all bar bar, this values. When we have multiplied with I, so this value is I. If this value is 1, no problem, this is 1. And what is the value? Y1. So similarly, you can write down this is S2, S1, S0, I, so bar bar values. Similarly, Y3, so S2, S1, S0, I, so this is bar, this one is the bar, or this is S2 bar, S1 S naught I, or this is equal to S2 S1 bar S naught bar I, S2 S1 bar S naught I. This value is S2 S1 S naught bar I, and this value is S2 S1 S naught I. So how many AND gate is needed? So total 8 AND gate. 8 AND gate. Is that clear, or anyone have any doubts, any query? Everyone give your response. Can you design this circuit? Can you design this circuit?
Yes, sir.
So here the AND gate.
Yes, sir.
Yes. Yes. So how to design this one? So first everyone, first everyone, uh, suppose I'm taking a one values, that one is called S2. So it's the values is like this one, and then now I'm taking it's a bar, so not gate. So this is S2 bar. Then S1. So you can use a scale. So your lining is proper. You can draw the straight line. S naught, and then I'm using input for I. So how many AND gates? So you can choose here the AND gate, 8 AND gate, 1, 2, 3, 4, 5, 6, 7, and 8. So 8 AND gate is needed, and here the output is Y naught, here output is Y1, here output is Y2, output is Y3, output is Y4, output is Y5, Y6, and Y7. So this is the output. And what is the input? First input is I, and then S naught bar, S1 bar, S2 bar. So this is the input of first AND gate, and here you have find it S2, S1, S naught I, like this one. Similarly, you can design all other. You can connect this one. Yes or no?
Yes,
Yes
sir.
or no?